morning. Good afternoon, everyone. Welcome to ASC's Calcutta webinar on customer-owned telemetry for utility interconnection for the year. First of all, I would like to thank you all for taking time from your schedule to attend this webinar. I am Nirmal Talil, Director of Product Management and Marketing for ASC Calcutta. Today, I will walk you through the webinar. Few logistics to keep in mind before we start off. This will be a listen-only webinar. However, to facilitate the clearing of your doubts or queries that may arise during the course, please feel free to type in your queries on the questionnaire pane in the webinar control panel. If time permits, we will answer during the session, or else we will be sharing our response to you on your registered email ID. Welcome once again. So here's the agenda for today's session. So we'll have some background and context of what the utility interconnection for the year is, why it is required, and what is driving for the utility interconnection requirements. And subsequently, we will go into the what are the products and solutions which is provided by ASC Calcutta, and we'll also walk you through the benefits and key features of these products, and concluding with a case study of a real world deployment, and which is in production for last more than 2 years. To start with, so some background on the standards and regulatory requirements to drive the interconnection of DER with the utilities. So UL 7041 Supplement B is a standard which is defined primarily for the safety of the grid-tied inverters or converters that are designed to provide grid support functions. So these functions include voltage regulations, frequency regulations, power factor corrections, and more functions. So UL 7041 is important because it helps to ensure that these inverters or converters operate safely and reliably, and they also do not interfere with the operation of the electrical grid. Subsequent to that, there's a IEEE 5041 standard, 47 standard, which defines the interconnection and interoperability of the distributed energy resources with associated electrical power system. Primarily, 5047 covers the safety aspects of the network or the assets and the people, and also guarantees the grid stability aspects as well. And further, it also defines the interoperability and reliability of the networks, which includes the ensures how smoothly the DRs can communicate with the utilities, and what are the different options for communications, all being defined in the standard. So you can see that 5047 defines 3 set of protocols. That's IEEE 2030.5, that's the default protocol, and IEEE 8015, that is the DNP3 standard, and third option is the SunSpec Modbus. So these are the 2 driving standards which defines the interconnection of DER with the utilities. In addition to that, there are a lot of regulatory standards as well. For example, California's Rule 21, which is released by California Public Utility Commission, CPUC, which mandates the communication should be IEEE 2030.5. So in California, all the DERs above 1 megawatt should send telemetry data to the utility, and also as part of the phase 3 of Rule 21, there's also mandate for the control functions also to be implemented. So California IOUs are required to provide customers with the customer-owned telemetry options to send telemetry data to the utility. So this are some of the background of driving factors for interconnection with the ER with the utilities. Moving on, so what are the different DR sites, and how are the different types of communication modes which gets enabled is what we see in this slide. So here you can see that there are two types of interconnection. That's a direct connection from the inverter, maybe through a direct from the inverter or through a gateway, uh, which is as per the CCP 2.1. And it could be a direct connection from an EMS systems, the energy management systems. So energy management systems, in fact, can have multiple DERs of same type connected to it, and EMS can directly expose data to the utility on 2030.5, either directly or through a gateway. So these are two direct interconnection options, and there's an aggregated interconnection option as well. So that's of two types. In aggregate interconnection option, you can have the EMS, which is connecting to different types of DR assets. Could be battery, could be PV, could be loads or EV chargers. Multiple equipments can be connected to the EMS, and EMS can aggregate all the data, all device data, and send it to the utility, either directly or through an DR aggregator. It could be a gateway, or it could be a third-party DR aggregator software. And last option is again DR aggregator option, but DR aggregator can connect with the downstream systems or softwares. It could be an EMS systems, it could be an inverters, could be a net meter, could be a battery controllers, battery inverters, could be the EV chargers, etc. So uh, the primary responsibility of aggregator is to communicate with all the different types of assets out there, collect the data on different protocols or interfaces, and then expose data to the utility on 2030.5. Here's the system requirements on high level. You can see that there is a customer site having multiple types of DERs assets, which needs to be decorated with the utility system, which is having a DR head and or maybe a DERMS or SCADA systems. Uh, So, if there are multiple assets, there should be a gateway or aggregator which should connect with all different types of DERs. It could be a PV or battery or load, could be a, other EMS systems or inverter control, which can exchange telemetry data as well as control data. And the gateway or the aggregator has to provide a 2030.5 interface as per CCP 2.1 standard, and the 30.5 communication has to integrate with the utility systems or a public network. In addition to that, the gateway also should have a network management systems which should manage the monitoring uh, or the management of the gateway functionalities, configuration part, wherever of the gateways, and diagnostics of the gateways can be done from an NMS systems as well. Could be NMS can be within the utility system, or could be an external system hosted in the cloud or maybe on the control center. And it also mandates a PKI infrastructure to manage the certificates for the communications. It could be the SunSpec approved PKI provider. Can be used as a PKI infrastructure, so can have the certificate from the approved vendors, or as per the utility preference, utility can also host their own CA, and those certificate can be used for the communication for 2030.5. So this is the high level requirement um, on the interconnection from multiple utilities out there in California. So come back to the solutions and products, what ASE is offering. This is a high-level architecture of the solutions. You can see here that there's a near gateway panel with a gateway controller and a 4G model, and also comes with a power supply which takes directly AC power from the side, and also have switch, Ethernet switch as well inbuilt, which can enables it to connect with the multiple types of DRs directly. So gateway, you can see that it can connect us to the multiple types of DRs like BSS, solar inverters, or EV chargers. And gateways has protocol support to communicate with multiple makes and models of DERs out there. Could be BMP3, could be SunSpec Modbus, standard Modbus, could be uh, sorry, 6950, could be OCPP, that open charge point protocols for the integrating with the EV chargers. Could be an open area as well for connecting with the demand response load directly to the gateway. And the gateway can provide a direct 23.5 connectivity with the utility they are had at. If utility prefers to connect directly from the field, or else the gateway can send data to a aggregator. So the Telco data hub, which is sitting in the cloud, can act as a aggregator software as well with a 23.5 server and aggregator client. And it also uh, aggregates the data and send it to the utility on 2030.5 aggregator link. So there are two possible ways of connecting the field with the utility, either directly or through an aggregator, third-party aggregator or cloud-based aggregator, which aggregates the data and send to the utility system. So in addition to this, so Calcure, which is a aggregator software, can also act as an NMS device management software as well. It does the management of the gateways and the other equipments out there in the field, like configuration of the gateways, modem, etc. It can do the firmware management of the devices. It can use to update the firmware, update the security patches of these devices remotely uh, on bulk quantities. Or can also have the remote access of these equipments to do the troubleshooting or diagnostics of these field equipments directly from the cloud. So that's the secondary function which is being provided by the data hub in addition to the DR aggregation functionality. And the 2030.5 interface at the gateway as well as in the cloud is being certified by SunSpec as per the CCP standard as well. So this is the high level solution which is provided by ASC. Moving on in details of the features and the functionalities and benefits of this product. We'll go ahead. Again, this is also an additional integration option where the DR data hub, which you see on the previous slide, which is acting as a DR aggregator, instead of directly connecting with the gate field devices or gateway, you can also connect with the OEM cloud. It could be battery or inverter management system, or it could be cloud-based software which is being provided by the OEMs, and can integrate the data which is collected from the field devices on the proprietary or native protocols, can be exchanged with aggregator on REST APIs, and or maybe any custom connectors can be used to integrate with the fleet aggregator and the utility 23.5 aggregator. And 23.5 aggregator in the data hub will send data to the utility systems on utility defined protocols. Would be 23.5, SunSpec, or DNP3. So in California, Rule 21, it is 23.5, or else if utility prefer to have the DNP3 or other options, can be exchanged with utility on those protocols as well. So the same system aggregator can also be used to integrate with the energy market applications as well to participate in the day ahead or real-time market, as well as for the ancillary market options as well. So it serves both utility integration as well as the market participation functionality. So here are the list of protocols which has been supported by the gateway as well as the DIA data hub, the aggregator software which sits on the cloud. So for the utility interconnection, as you can see that it supports all the standard utility protocols like 2030.5, DLP3, SysOnIFT, IEC 60870 protocols like 101, 104, which is used for telemetry interconnections. Now, ICCP, that's Control Center Protocol, primarily to exchange data with other SCADA systems, or 614 25, which is a spin-off of SysOnIFT for the wind farm applications. On the downstream for DER connectivity, it supports all the standard protocols defined in IEEE 1547 standard, which is 2030.5 SunSpec Modbus or DNP3. And it can also integrate with the equipments on System IFT, especially the System 94 7-420 model can be utilized to integrate with their assets, and a few other protocols to integrate with the meters like DLMS, COSAM, BACnet, and all supported in the gateway as well as in the aggregator. And it also has a northbound protocol to integrate data with the uh, mm, external applications. As we see in the previous slide, the aggregator can also be used to integrate with the market applications or any other operational and maintenance applications as well, in addition to the utility their interconnection. So if you want to do an O&M of these size, you can exchange data with IoT platforms like Amazon or Microsoft Azure on the native connectors provided by the AWS or the Azure. So there are connectors to AWS Kinesis data stream. There is connectors to AWS IoT Core, connectors to the AWS S3 buckets, which is a file-based storage. And there are specific connectors to Azure Service Bus or Event Hub or IoT Hub. So there are different options which is already predefined and made available in the data hub, which enables users to expose data to a third-party system transfer, and also supports other standard protocols like OPC, UA, MQTT to if we want to have a other standard-based protocol integration support. And so there's a lot of management protocols like SNMP, SFTP for file transfer, NTP or SNTP or IEEE 1588 for the time synchronizations. All the management level protocols are also being supported in the gateways. Moving on. So as we discussed in the previous slide, the 2030.5 aggregator or a direct client in the gateway as well as the data hub is tested and validated as per SunSpec CC standard. So all the mandatory and optional function set as defined in the IEEE 1547 for the CC standard is being verified and certified by SunSpec. Moving on to the details of the security aspects of the gateways, especially. So gateways are there are different hardware variants. We'll see all the hardware variants in the coming slide. So the hardware variant which we have supports different levels of security, including the hardware security for trusted platform module and a secure boot, which ensures that only the approved software will be loaded into the device, and only the approved software can be uh, deployed and installed in the device. And if there is any software has been malware has been replaced, then it immediately the device will not be functional. And all the system level software, including the OS, kernel, and the application stack, is been hardened, and there's a hardened Linux which has been used in the gateways, and there's also application profiling using ARPARMOR, which enables the applications which is running inside the so in the gateway profile, in the sense it can configure the what are the user level permissions or file level permissions which needs to be made available for each applications, and only those permitted resources can be made aware used by the applications which is getting loaded into the gateways. So there are different levels of security, and which is built in as part of the gateway hardware platform, and all the unused ports and the services has been disabled by default, so that it will not be open up for any of the malware attack on the device using any standard softwares out there. And all the softwares which is been loaded in the device, application softwares are signed by ASIO Calcutta, and if there's any software which is trying to load and run it in the gateway which is not signed and approved, that will immediately be stopped by the backend systems. And it can also have different stages associated with the uh, firmware which is getting loaded into the device. Like you can have the developer or QA staging or production, so that it ensures that if a firmware which is released for a testing or development or maybe QA uh, will not uh, be used for a production deployment. So all the firmware which is getting released for even for testing will be signed, and that so if it is testing signed firmware cannot be deployed on a production environment. That which ensures that the safety aspects of the on the production side system, and also provides the zero trust access control security, which is primarily used to access the behind the gateway devices like inverters or battery controllers can be remotely accessed uh, through the gateway and the cloud from a remote machine. So we'll see that remote access functionality as we move on. So those kind of securities are also built in as part of the gateway. Yeah, this is the picture representation of the security stack, which is built in as part of the gateways. It comes with the hardware level security, TPM, Secure Boot, and there's a hardened Linux on top. And there's a firewall and access control which is built on top, which ensures that the all the say uh, external access through the communication port or for the user level access has been controlled and checked. And the application sandboxing using ARPARMOR has been added on top to make sure that all the applications have only the permissions which is required or which has been allocated for that particular applications. And on top of that, there's a firmware signing mechanisms and integrity check, which ensures that only signed firmware will be deployed in the gateways. So in addition to the application or system level security, there are security built on the application side as well. Like data logging, it supports the syslog data logging functionalities where you can log the applications logs within the gateway, or if you want to log the application logs into a external syslog server, you can push the all logs to the external syslog servers as well. And there's data management and protocol translation engine built in, which enables all the translation of protocols from the internal protocols to utility defined protocols and vice versa. So this is a high level software layers which is available in the gateway. And we're going to talking about the security aspects. There are three PK levels of PKI infrastructure which is built in as part of the gateway ecosystem. PKI, the public infrastructure one, that is we call it as trust chain one, is a non-installable trust chain. This ensures that it's primarily trust chain one is used for assigning the firmwares or software which gets into the device. So all the firmware has to be signed by AC or Calcutech. So if it is not signed, then that firmware cannot be deployed in the gateway. So trust chain one helps us to ensure that the integrity and the security of the firmware side. So this is a non-installable. So only the firmwares with the DC1 signature will be allowed to deploy in the device, and can be staged with the different levels like production, staging, QVAs. Trust Chain 2, which is installable, is primarily used for device management functionality. So, for device management service is being available on the cloud or within the utility system, um, or which can be hosted by ISC in our cloud. So, whatever the device management service is, you can generate the certificate from that device management service from a non CA, and all the user level access to configure the gateway or manage the device firmware or update the configuration files, update the access log files. All the gateway access will be controlled through this trust chain. So there's a X509 certificate which is being issued to each and every users, and each users will be allowed for a specific actions which has been permitted for that particular user role. um, for example, if a operator user has been trying to access the gateway and trying to change the firmware, uh, the uh, the role-based access control mechanism, which is built in as part of the gateway, will block that functionality, and using the certificate which has been issued that particular user. So there are two ways of a user access check which is done. It is using the OCSP based validation, or else there is one more option called as per the IEC 62351-8, that is the attribute certificate based permission validation. So either of these two uh, options can be enabled, and it will helps the network admin to ensure that only the users with the privilege access or access permissions have been allotted can be access the device and do any operations. And Trust Chain 3 is also installable, which is primarily used for, in the DR case, it is used for the communication security for 2030.5, and by default, it allows user to install the certificates issued by the SunSpec or approved certificate authority. In addition to that, if utility prefers to have their own private CA, then the installable Trust Chain 3 option uh, helps in installing the utility specific certificate, and use that certificate for the 2030.5 communication. So both utility defined or the standard SunSpec standard certificate can be used in the gateway. So that's the flexibility on that side as well. Moving on, the gateway core software functionalities, as we see in the previous slides, there are different protocols which on the downstream, which gateway is communicating with the devices on Modbus or DNP3 or System IFT, and each protocol supports different types of addressing scheme or protocol mechanism to get the data. For example, the SunSpec Modbus gets data on different Modbus registers. DNP3 gets data on different addresses, and System gets data on different tags, which has been defined in the IEC file or ICD file. So whatever the different data models supported by different protocols, the gateway has a generic protocol conversion engine, which allows users to map any protocols to any other protocols by default. So the user have full flexibility to map any of the data from the field devices to the utility. So you can have the um, multi-protocol mapping from any protocol to any protocol mapping can be done through in this framework. And there's also master to slave mapping. So primarily this is a master protocols which is responsible for getting data from the field devices. And this is a slave protocol or server protocol which is primarily responsible for sending data to the external systems. So can map the data from Modbus to a 2030.5 client to send it to a DevOps application, or we can send it to a DLP3 slave to integrate with the SCADA system. So that's the typical master to slave mapping concept, and also have master to master mapping option available. Suppose if there's a in data coming from the inverter has to be routed back to another controller, can the master to master mapping from this master to another master enables us to send data from a inverter to another controller if required. And also slave to slave mapping is also available. That means if a SCADA system communicating on the NP3 want to send a data to the gateway, and from that gateway you need to do some processing and send it back to the DERM system. The slave to slave mapping enables users to do the mapping from the mm, one slave to another slave as well. So there are various use cases which requires these functionalities in detail. So you not go into the details of the use case aspects for now, but these are the features which has been available in the gateway, which enables users to meet multiple types of use cases. And the uh, their gateways also comes with a inbuilt model mapping. It has got auto mapping option from SunSpec to the 30.5. You can specify that model depending upon by selecting the manufacturer and product, and automatically all the models supported by that particular product model will automatically be configured and mapped back with the 30.5. So if that particular device is not been listed in the SunSpec or approved registry, you can have custom model mapping as well. So you can have build your own custom models and handpick those models and map it to a 30.5 option as well. So two levels of configuration or data mapping is possible on a device level or maybe on tag level mapping. So that's kind of flexibility which has been provided in the configuration tool. And moving on, that as we also seen that the data hub can also act as an aggregator as well as DR aggregator, as well as it can also act as a device management system for managing or monitoring the field devices, including the devices or the gateways. So this is a sample dashboard which is primarily used for monitoring the gateways, where we can monitor the device or the gateway healthness, whether it's alive or communicating, whether the 30.5 communication or the device communication is healthy. Like the gateway is communicating with the utility, but the utility communication is healthy, or if there's any communication issue, then immediately it can be sent as an alarm to the device management portal for taking specific actions to rectify those issues. And also gateway to the device communication can also be monitored in case of the field level communication issues. It can also be immediately notified to the uh, user. And this portal can also be used to centrally manage the field devices like firmware management, updating the firmware, updating the security patches of the device, updating the configuration, updating the license. There are different use cases for managing the devices, which is possible from the central management portal. And so the dashboards is fully customizable. You can have any multiple types of widgets loaded into the dashboard, and you can monitor these assets on the user-defined widgets or the dashboards as required. And there's an email or notification service you can configure some of the alarms to be notified to a group of users, to a specific user role. You can configure those, or if there's any critical alarms, for example, gateway or their device is not live for more than 2 hours, or maybe more than 6 hours, or maybe more than one day, those alarms has to be notified to the specific set of operators to take remedial actions. Those kind of notification service can be enabled in the platform, and also provides the secure role-based remote field device access, which we'll see in the coming slide how the remote access is being enabled by the middleware. So this is the secure device management. You can see that the Calcio device management system, so software, or Calcio Data Hub, can also have a role-based access control mechanism, so where you can have the users configured in the Calcio cloud, and each user can be provided with access permissions to access the gateways or configuration. And each user will be issued with a certificate, X501 certificate from the data hub, and that certificate and will have the permissions check if we are using an attribute certificate based authentication, or if it's an OCSP based, whenever a user submits a certificate, gateway will immediately check that validity of the user and the permissions which the user is trying to access. Then as per the OCSP response, gateway can decide whether that user should be allowed to permit a specific operations or not. So those kind of security layer is already built in as part of the entire ecosystem. This is the remote access feature. So you can see that there are gateways, which is having gateway controller, modem, and the downstream behind the gateway there's inverters or meters or EMS systems, multiple types of devices or aggregators could be there behind the gateway. And if you need to access or do some configuration change or firmware update of these devices without going to site, this entire ecosystem allows users to do that on a secure way. So can have the users provide a permissions to access specific devices behind the gateway, and the user will be provided with a certificate, and from the remote machine he can use the certificate and create an end-to-end tunnel from his engineering workstation with the gateway and to the site. And through this secure TLS 1.3 tunnel, you can access any of these field devices remotely and securely, and do all the use case requirement, like the if you want to do the configuration update of the devices, or firmware update, or diagnostics of devices, it can be done remotely from the technician PC over a secure link. And this certificate can be controlled. You control the validity of the certificate. You can have the window validity window in such a way that you can access the devices only from maybe tomorrow 5 to 10 p.m. So you can issue the certificate for that particular window, and any user coming with the certificate will be allowed to access those devices or assets only from in that particular window. And also can obviously revoke the certificate, and if you require that, if you that permission has to be revoked, all these functionalities are already built in as part of the uh, plan. So here are the different hardware options, gateway options. You can see that there are gateways panel is an IMA 4 panel, combined panel with a gateway controller, and there's a modem. So here there's a GE Orbit MBS modem, and there's an inbuilt power supply, switch, Ethernet switch, and other equipment isolators, etc. And there are different types of gateway controllers depending upon the functionalities, the number of serial ports, Ethernet ports, or communication channels requirement. There are different controllers available in the gateway. So the different models, so there's different variants of the gateway. So here are the six variants of the gateway. Primarily, you can see that the first three are the Intel uh, mm, atom-based hardware, which comes with at least two Ethernet ports. So two Ethernet ports, one port can be used for the modem communication, and second port can be used for the communicating with the DRs, either directly, or if there are multiple DRs, you can have a Ethernet switch, 5-port Ethernet switch in the panel, and from the Ethernet switch multiple DRs can be connected. And there are inbuilt serial ports depending upon the model. So there are different combinations: two serial port with 423 to 485, and six serial port options, four serial port options also available. And there are these different hardware has got different levels of security. Some of the hardware has got hardened Linux, and some has got the RT Linux system, and some has got the controllers, attack controllers. You can see that the cell attack is provided as part of the some of the models, where you have one for the Intel box as one for the ARM-based box as well. And device level security. So these three models has got TPM. These are full-fledged secure devices. These first three boxes with the TPM, secure boot, applications and browsing firewall, etc. And this particular one has got applications and browsing firewall, and last two has got one firewall options. And depending upon the power supply requirements or power supply available in the field, you can opt the universal power supply, which can take the 85 to 264 volt AC or 120 to 370 volt AC. And some sites may have more than 300 volt. Can go to high voltage power supply with 180 to 550 volt AC and 254 to 780 volt DC as well. Uh, and there are certifications which comply with the CE, FCC, SunSpec, CSAP. Some are scored the certification for System 90-3, which is enables this particular device to be used, can be used for a substation kind of an environment as well, with a hardware level EMI EMC compliance provided in this particular device. Moving on. So we're packaging this entire solution as the product support and maintenance. The product includes the gateway panel, gateway hardware with an enclosure, power supply, this cellular modem with a static IP SIM card, which is packaged along with the gateway panel, and also it provides with a SunSpec certificate built-in or pre-installed before the shipment. So this is the entire product package. If you go with the full option, it comes with modem, SIM cards, and certificate everything. And supports the premium support is already built in as part of the product. That is 20 hours premium supports for the configuration of the gateways, and the support for the technical support for the installation and the commissioning of the gateways are all packaged as part of the product itself. And additional support, obviously, if required, can be availed extra. And you can also subscribe for the for annual maintenance for entire 5 years. Additional 4 years. The first year is included in the product, and additional 4 years can be subscribed, which means that all the maintenance of the hardware and the software will be done. And if there's any issue happen inside, device can be shipped back and will send a fixed or rectified device or the new device depending upon the issue. The site and can be made available for 5 years. And there is a remote management portal, as we see in the previous slides. The ScalCAO device management portal is available for the full-time 24/7 monitoring and diagnostics, or maybe you can use that for notification purpose. So if there's any, you don't need to monitor continuously. If you configure for notification for critical alarms and And if you get a notification that something has gone failed, then you come back to the portal and see what has gone wrong in the device or within the communication. So that is also a subscription which is provided as part of the package. So this is how the entire data hub as well as the Galileo edge, the DR gateways is provided as a customer want telemetry option for utility interconnection. Moving on, we'll look at the case where DR gateways is been used for the integrating with the PG&E as a customer on the gateway. And this is live for more than 2 years now. This is primarily customers directly purchase the gateway from ASC, and we have supported customers to integrate the gateway with the field devices and with the utilities. And they also have the support service to do the integration testing or SCADA testing, which I call as SCADA testing. So SCADA testing with the PG&E server. It includes the pre-engineering configuration of the gateways with the field assets, and the pre-engineered device will be shipped to the site, and once it is installed, we help the customer to do the integration testing with the utility system. So this is a full-fledged package with the hardware, software, and the services for the configuration as well as the testing. So this is how it's been offered. So once we customer confirms the specific site details with the site architecture or SLD and the IO list of the devices, um, uh, the pre-engineering team or operations teams does all the configuration of the gateway as per the IO list and the SLD provided by the customer, and ship the pre-engineered device to the site with all the modems, SIM cards activated and ready to communicate with the utility systems. And it also provides access to the device management portal also for that if there's any monitoring required, we can provide access to the device management portal as well as part of the delivery. And once it is delivered, so we provide the installation support for the technicians, customer technician to install the gateway at the site, and also we also support the customer to do the SCADA testing or to integrate integration testing with the utility system as well. And once the installation and PTO is obtained, we also have a continuous maintenance service as part of the subscription. We do the continuous. We have the operations teams which does the continuous monitoring of the devices, and if there's any issue happening at the site or at the communication site, immediately that those information will be informed. Those alarms will be informed to customer for taking the necessary remedial actions. And we also do proactive updates of the devices, like if you want to have a security patch updates or firmware updated devices. It gets scheduled with coordinating with the customer and with the also with the utilities, and we do the firmware and the patch update remotely through the port device management port. So this is a case study, and this particular site is live for more than 2 years now. And yeah, this is a picture of the site where the gateway is installed and it's been connected with the utility system as well as the system. Okay, so yeah, so in short, just to summarize, so what we provide is the standard-based integration with the utility, whether it is 30.5 or DNP3 or SunSpec. As per the utility requirement, again, the gateways or aggregators provides direct integration with their assets in the field, and as per the utility requirement, this data can be integrated with the utility systems directly or the utility defined protocol. But in California, it's 2030.5, and the same the aggregator can also be used to integrate with the market applications for the day ahead or maybe an ancillary market. And there can also data hub can also provide API REST APIs to expose data and take data to a application for the main operation and maintenance of the assets as well as a optional feature if required. So with this, I would like to conclude the webinar. Uh, let's see if there's any questions. Okay, if you have any questions, please feel to type in the questions pane. If there's nothing, maybe we can conclude the webinar. I see there's no questions yet. So uh, thank you all for your time. And if there's any questions, please feel free to send it to us. We'll be more than happy to send a response on how on your queries, or if any clarification on the standards, or if any clarification on the product, or the solution architecture. If you want to work on, we will be more than happy to support you on that. Thank you all. Have a good day.